Let's take a look at some examples of conjugate addition reactions now. But before we dive in, let's draw a general scheme for a conjugate addition reaction. All of these reactions involve alpha-beta unsaturated carbonyl compounds engaging with soft nucleophiles, and all the nucleophiles you see on this slide are soft nucleophiles. In essence, the nucleophile and H+, quote-unquote, often involved in workup, add across the alpha and beta carbons in a conjugate addition reaction. This results in a new bond to H at the alpha carbon and a new carbon nucleophile bond at the beta carbon of the alpha-beta unsaturated carbonyl compound. So for example, in this first reaction we have two electrophilic sites highlighted in blue, and the nucleophile is an amine. This is an example of a soft nucleophile that engages in conjugate addition, and so the product will contain a new bond between carbon and nitrogen at the beta carbon and a new bond to hydrogen at the alpha carbon. So we have a beta amino ketone product. And the new hydrogen here results from acidic workup, which either protonates an enolate intermediate or catalyzes tautomerization to the keto form of the product. In the second case, we again have two electrophilic sites highlighted in blue, and our nucleophile is the cyanide anion, which comes along with sodium cyanide. The acetic acid here is just included as a catalyst, and the ETOH, the ethanol, is just a solvent. The nucleophile is soft, and so in the resulting product we have a new bond between the cyanide carbon and the beta carbon, and a new bond between the alpha carbon and hydrogen. Finally, in the last example, we have a cyclohexenone with two electrophilic sites highlighted in blue, and we're using a nucleophile that is an organocuprate. These are soft nucleophiles with relatively low partial negative charge on carbon for an organometallic compound, and so these react in a conjugate fashion to give beta-alkyl carbonyl compounds. Here, we add a new bond between the methyl carbon and the beta carbon, and there's a new bond between the alpha carbon and hydrogen as well. Notice in the last two examples that we formed a stereocenter. Conjugate addition reactions often result in the establishment of a stereocenter at the beta carbon and or the alpha carbon. If the alpha carbon is already substituted in the starting material, this can result in the formation of a stereocenter there as well. And so, just a little food for thought to end this video, how might we make this reaction stereoselective? How could we modify the nucleophile or introduce a particular type of catalyst to form, say, a single enantiomer of product selectively or a single diastereomer of product in reactions that establish stereocenters at both the alpha and beta carbons?